Um, Hello guys, my name is Sajid Rashid, and I'll be going through the English to Luganda project. Okay, so this is most likely going to be the last episode, the last video about this topic. Yeah, so I created the model. I'll be going through like all the model and some background, all that stuff. Yeah, anyway. So a simple introduction. So translating in AI, it's termed to us to be machine translation, and it's a field that was and is still in research. And so far, there are multiple machine translation approaches. We have the rule-based machine translation, statistical machine translation, and neural machine translation. Right now, the neural machine translation is the most popular one and it's the most recent. Yeah, and it has been okay. Basically, its results are much more promising than these other previous ones. Yeah. So and literally, it's the one that I also used for the translation of this model. So some literature review. Translation is a crucial aspect for communication of individuals who speak different languages. With the advent of artificial intelligence, translation has become more accurate and accurate, making it possible to communicate with individuals in other languages in real time. There are basically two major learning techniques that can be used. We have the supervised learning and unsupervised learning. Under supervised learning is a type of machine learning where the model is trained on labeled data set, whereby you have your data and also what you have the data contains labels. For example, it might contain like some X data could be an image or anything, and also its label. Like the label could be the meaning of that particular image. That's for supervised. And unsupervised, it's the other way around, whereby you don't have any labeled data. It's just X data, and then you could try to cluster that data and to come up with some kind of meaning. So for unsupervised data, you are not sure whether the output you've got is the right one or the wrong one. You just have the given output. You're unable to know whether it's correct or not. Okay, so there are such gaps in this model. Okay, so first of all, limited training data. The quality of the AI, the quality of AI powered translations is heavily dependent on the amount of and the quality of training data used to train the model. So yeah, that means like there some further research needed to so as to get quality training data because it follows the garbage in, garbage out. If you feed it with garbage data, obviously it will also feed you with garbage output. So yeah. So now lack of culture sensitivity. AI-powered translation system can produce translations that are grammatically correct but lack the culture sensitivity for human translations. For example, some text in Luganda, okay, like they have some hidden meaning in them, whereby you can't just say it out because it's got some hidden cultural sensitivity in it. But for an AI model, it's unable to understand that there's some cultural sensitivity behind it, so for it, it will just keep on predicting its output. So, and this could be an issue. So that's why, yeah, this is also something that needs further research. Also, vulnerability to errors of the machine translate. AI cannot translate what it has been trained on. So that means if you give it anything other than what you have trained it on, it will obviously give you an error. Next, now the methodology that I used through this way was to train a neural machine translation model. Now the neural machine was trained on English and Luganda parallel corpus dataset, meaning just a dataset that contains both English and Luganda. Yeah, and we'll use the editor to train the relationship between two languages. Yeah, so it can be the process, it can be summarized as data collection. Now that involves the correcting of the data, preprocess the data, remove text, irrelevant information, and standardize the text. Model selection, so choose the neural machine translation that is best suited for this. There are a couple of neural machine translations. For example, you could use recurrent neural networks. You could also you could try to incorporate in something called term does the attention mechanism. Also, you could use transformers in the end. So they're all different. You can also use these usual machine learning techniques. That is the SVMs. Yeah, but those usually they won't work very well for tasks related to this. So after that, we have the model training that involves the training of the model, then model evaluation, deployment, and continuous improvement. Okay, so data preparation. Data preparation refers to the steps taken to prepare raw data into improved data, which can be used to train the model. So now this involves the removal of punctuation plus any spaces that is unnecessary. That's necessary to prevent the model from training on a large amount of unnecessary data. Also converting the case of words in the dataset to lowercase. And finally, vectorizing of the data. Vectorization refers to the process of converting a given text into numerical indices. Yeah, because a machine learning model would only require the numerical part. It can't understand it can't understand the text itself, right? So it's supposed to be numerical. Okay, so the heat map is under the exploratory data analysis, and it's basically used to usually in NLP related tasks, whereby you want to view like the most frequent number of words in your data set. Yeah. So I discussed a lot about this in the previous videos, so I won't be going through the data exploratory analysis in this video. But just this is a brief of what data exploratory analysis is about. Please check out my previous videos if you want to get to know more about this. Okay, so on training the model, I got a 92% accuracy and around a 52% accuracy on the validation set. And yeah, this shows that the model is overfitting the data set. Yeah, it's overfitting the data set. Which is okay. This is basically because the data set wasn't that big, so would have required if the data set was very huge, yeah, like very large, then the models accuracy would have been much more better than this. And also changing the model because I got this accuracy when using the attention mechanism. So to make it even much more better using now like fine tuning different models like the hugging face transformers that could tend to make the model much more accurate. Yeah, and this was a simple attention plot to see how the model predicted a given sentence. For example, I fed it with the sentence said the district carried out a massive community sensitization to reduce gender-based violence, and it translated it to this. Disitulikiti yayigiriza abantu b'omu kitundu ku kukendeeza, yeah, and so on. Yeah, and it's okay. So this is how it translates them. It gets now. As you can see, some regions are highly carried. That means that they got a higher probability. So meaning that it's very sure that that's the respective output, like the respective, how can I say, the respective translation for that particular word. Okay, so now here are the list of the references I used throughout this presentation. Yeah, and finally some acknowledgements to Mr. Guy Wango Marvin and Dr. Loz Nachibure. Thank you. Please like and subscribe to my YouTube channel. Yeah, till we meet.